Hello there, welcome to lesson number 1 in our series on using FluidDesigner for 3D printing to create simple bracelets. In today's lesson we're going to use a Torus mesh to create a very simple bracelet. So if you start off FluidDesigner, we need to go to Learning Projects, Jewellery Projects, Bracelets. And we're doing lesson number 1 today, so it's 01 Simple Torus Bracelet. Just drag and drop that onto the workspace. And this is the object that we're going to create in today's lesson. It's quite unusual, a little bit large in terms of the external diameter, but that's just because of how we're producing it. We're just going to do it a very simple way today. So first of all, I'm going to start the screencast keys. So any key presses I make, A for example, or return key, they'll be displayed in the window here. And just to remind you that in the help panel here are the instructions that you can follow. The instructions here lead you in a slightly different path from what we're going to do. But if you don't want to watch the video, you can just follow the help instructions and learn how to create this bracelet that way. So what do we need to do? Well, we need to add a mesh and add a torus mesh. So if we go to add mesh and torus, add a torus mesh, we've got an object in the middle of the screen here, and at the moment we can see that the X and the Y dimensions of it are very small indeed. So if we go view and zoom to selected, you'll see that there's our basic object. That's our basic torus shape, okay, which is what we're going to make the bracelet out of. But this object at the moment is only 2.5 millimeters by 2.5 millimeters. So X is the red, so it's 2.5 millimeters across and 2.5 millimeters in the Y, that's the green. And the thickness of it at the moment is only 0.5 millimeters. Now that's much too small to be a bracelet. So what we need to do is we need to scale this up. Now at the moment I'm just zooming out by rolling the center mouse button, and just to show you what it looks like. What we're going to do is we're going to make this much larger now, so we're going to scale it up. And we're going to make it more or less the same at the bottom. Not exactly, because we'll have to do it a couple of times until we get the right dimensions. So if I press the S key on the keyboard to scale, and if I drag the mouse out away from the object now, I made a slight mistake there, I'm just going to cancel that. I ought to point at the object with the mouse. I had the mouse out here when I started doing that. I should have pointed at the object itself, then pressed S on the keyboard. That way when I move the mouse you can see I've got much better control over the object. Now I need to be looking at the X and Y dimensions in the panel here, and I'm looking for something like 60 or 70 millimeters, that sort of dimension. So I've got 72 there, so I'm going to click the enter key. Now whenever you scale anything in FluidDesigner, one of the things that happens, and I've just opened the toolbox panel here by clicking on the plus sign. I could have done it by pressing T on the keyboard. So T for toolbox will open and close the toolbox. Whenever you scale anything in FluidDesigner, these values here, these vector X, Y and Z values change. You've got to be very careful with this in FluidDesigner. You need to always keep resetting these back to a value of 1. We don't want any scale factors. Can cause problems with printing. So whenever you scale anything, what you should always do then is hold down the control key and press A, and then apply the scale. That will reset those values back now, so there's no object transformation anymore. They're set back to 1. So that's something you do need to watch out for in FluidDesigner whenever you scale anything. Now in order for this bracelet to fit your wrist, you need to know what inner diameter you need for this bracelet. And so we need some way of measuring it. Now first of all what I'm going to do is I'm just going to move this lower object out of the way, because I want to look at the new torus from the top, and I want to be able to measure the inner diameter. So with the torus highlighted, if I go to view and top view, and then if I just scroll the center mouse button, we've got this interactive ruler here, so I'm going to use it to measure the internal diameter of this object. First of all, I'm going to scroll in. This will give me a better degree of accuracy when I measure this. And if I look across there, that's about 42 millimeters at the moment. Now, I don't know whether you can actually notice this, but the edge at the back there and the edge at the top is in a different location, and that's because at the moment we're looking at this from top in perspective mode. Perspective mode. So another thing I'm going to change here is if I go to view, if I click on this one here, view perspective stroke ortho, I can switch from perspective view to ortho view. Now you really need to be in ortho view when you measure, because if you look now you can't see the back edge of this object. If we're in perspective mode, and this just toggles between perspective and ortho, you're looking into the object here and you're getting a false impression of the back of this object. You can actually just see this is the back of the object and this is the front of the object, and they're in different locations, which is what you would expect in perspective mode. So we really ought to be in ortho mode when we measure this. So if we just try again, it's only made a slight bit of difference. That's 43 mil. But you do need to be aware of this difference between ortho mode and perspective mode. Now if you've decided that you want an internal diameter here of 60 millimeters, let's say that's the size that you want, rather than keep messing about with a ruler, a good way of actually doing this is if you add a mesh and if you add a cylinder. Now at the moment that cylinder is only 2 millimeters by 2 millimeters, but if I change this to 60 millimeters, I should have typed the mm, 60 mm for millimeters, and changed Y to 60 mm for millimeters, I've added a cylinder there now. Now you can't see it terribly clearly, so I'm also going to increase the Z value. I'm just pointing at the bar and dragging the mouse now to change the Z dimension. Okay, so there's our cylinder, which is now 60x and 60y. In other words, the diameter of this cylinder is 60 millimeters. And I'm going to use that so that I can resize my torus so the internal diameter is exactly 60. So if I go to view and top again, I now need to click on my torus, make sure the torus is selected, and you can see it says torus here. And again, if I point towards the center of the object and if I press S for scale, I can move the torus now, and as you can see, once I get almost no gap there, what I'm doing is creating an internal diameter for my torus of 60 millimeters. So that's a way of getting an internal diameter by using this other object, this cylinder. Now remember again that when we've scaled that, these vector values will have changed. Whenever you scale an object up or down, the vector values change. So while the object is still highlighted, always do Control A and apply the scale, and that will reset the vector values there. You don't need to always keep opening up this panel, but you do need to keep resetting the scale, unfortunately, in FluidDesigner. Now, we don't need this object in the middle here, this cylinder. We only use that to get our internal diameter, so we can highlight that and press X on the keyboard and then delete that inner object. Okay, so there's our torus now. Now at the moment we've got the inner diameter of 60 millimeters, which is the size that we're choosing to do for this lesson. Like I say, you could do it at any size that suits you. What we need to do now is to reduce the thickness of this object. If we tried to print this, it would be horrendously expensive because of the volume of the material. So we're going to show you a simple way of resizing this object. and thinning it out. So what we're going to do is, if we go to view and front view, and what we're going to do is we're going to scale it again. This time we're going to scale it in the Z dimension only. And the way to do that is we press S on the keyboard for scale. Now if we scale it like that now, it's going to scale in all dimensions, and you'll see all the values changing up here. But if I press Z on the keyboard, what that does is it restricts me to only scaling in the Z dimension only. And so what I want to do is I want to reduce that down to about 3 mil. So that'll do, 3 millimeters, and then click. So we've scaled it just in the Z dimension. Now again, if we open up the toolbox here, you'll notice that the vector values have changed again here. So what we need to do is Control A and apply the scale to reset those values back to 1. So there's our object. It's not a particularly great bracelet, but we're just trying to show you how you can use a simple torus, how you can scale more than actually create a bracelet. So what we're going to do now is we're going to delete that object. So highlight it and press X on the keyboard to delete it. So we delete the original Torus bracelet. This one now we need to save it. And always in FluidDesigner we recommend that you go to File and Save As. Don't save it over the original learning file. Come up through the menu system. Look for the My Projects, Jewellery Projects Bracelets folder. And you can save this lesson as 01 Simple Torus Bracelet. And you save it as a Blender file. Now you can't print Blender files, so you've always got to, with FluidDesigner, you've always got to export these in a printable file format and also run them through NetFab Basic to check them and make any corrections to the meshes. So if you go to File and Export, we like to use the Wavefront OBJ format. I'm going to save it to the desktop. So we're saving it to the desktop, 01 Simple Torus Bracelet. This time we're saving it as an OBJ file, an object file, which is a printable file format. So we export that to the desktop. Now you then need to start your application NetFab Basic. And if you haven't got it on your system, you can always download it for free from the internet. So it's NetFab Basic. And if you go to Project and Open, go to the desktop, open the Simple Torus Bracelet. Now sometimes you'll find there's a warning red triangle here which says that there's something wrong with the mesh. We're not getting any problems with this particular one, but we would always recommend that you go to Extras and repair the part, just in case. And what NetFab will do is it will triangulate the mesh. So you can see it has changed this mesh into triangles. Whoops, I've lost my NetFab. I just want to move NetFab Basic across a little bit. It doesn't fit properly in the video capture window. What you should always look for in NetFab are any problems over here. Well, we've got some red numbers at the moment, but if you click on Update, you'll see we've got zeros here. There's no edge problems, no orientation problems, and no holes. That's all a good sign. But again, we would always recommend that you automatically run the repair and execute it. That will triangulate the mesh. And always we recommend, I'll just click Update again, you'll see there's still no problems. And always click Apply Repair and remove the old part. And that's now got our object repaired. It should be a fully printable file now. All we need to do is to go to Part, export it as a wavefront object, export it to the desktop, and it's a 01 Simple Torus Bracelet repaired, and it's an object file, and that's the file that you would send to the printer if you wanted to actually print this bracelet. Now there is a lot of depth here. It's not really the best bracelet to print, a little bit simple, but we're just showing you what a torus is really and what scaling is in FluidDesigner. Okay, so that's it for today's lesson. Thank you.